Okay, as the last couple of folks stream in here, I think I'm going to go ahead and get started. I hope everyone is having a wonderful TechEd. My name is Sandeep Singhal. I run the Windows networking group. And today I'm going to be talking about Hyper-V network virtualization in Windows Server 2012. Hyper-V network virtualization is a very exciting capability that we've brought out with Windows Server 2012, which is really targeting scalable multi-tenancy. What we're going to do today is talk about scalable multi-tenancy, what it means for your private cloud, what it means for your public cloud, and what it means as an enabler for building hybrid clouds. What you'll see is that in all of these environments, public, private, or hybrid, you have a need for multi-tenancy. And that multi-tenancy is a very difficult thing to achieve today. You'll see that all the existing techniques for trying to achieve multi-tenancy have problems of scalability and flexibility and deployability and manageability. And then we'll talk a little bit about how Hyper-V network virtualization addresses those needs. We'll go into some detail about exactly how it works. And then we'll walk through a set of deployment scenarios that will give you a sense of different ways that it can be deployed within a private cloud, within a hybrid cloud, within a public cloud. So at the end of this talk, I want you to understand how Hyper-V network virtualization meets the needs of scalable multi-tenancy. I want you to understand how the underlying mechanisms of IP virtualization actually work. And have an insight into how those packets are actually managed and how those policies are actually delivered. I want you to understand the different deployment scenarios and take away from this how scalable multi-tenancy is important in your environment, have a good sense of how this fits into software-defined networking, which is a huge new trend across the industry, and have a sense of how you can get started with a Hyper-V network virtualization deployment within your own environment. You can actually deploy network virtualization today on your existing networks with your existing servers, your existing equipment, just by running Windows Server 2012. You can also download System Center 2012 SP1, the latest CTP, supports Hyper-V network virtualization. So you can actually get an entire deployment up and running with existing tools that are available for download. Many of you who have been attending virtualization and Windows Server tracks have seen this slide. We're going to be really talking today about network virtualization as helping you move beyond virtualization. It's not just about virtualizing your VMs and taking your resources and putting them on a shared hardware infrastructure. What we're going to do is go beyond that and really talk about what network virtualization does to enable a much broader type of flexible data center. So let me start out by just level setting about where we came from and how this all comes together. Over time, what we have seen is a transition in how workloads are actually deployed. Way back when, not that long ago, we bought individual servers. We'd put them into our closet, and in my case, I'd put it under my desk. And we'd run individual workloads in those servers. And of course, we pull those eventually into data centers, large data centers, where we'd run lots and lots of physical servers. And we'd get reduced cost and a little bit more flexibility by putting all of our workloads in those shared data centers. And of course, virtualization came along. And we took all of those servers and we tried to reduce the number of servers. We used virtual machines to do server consolidation. But the problem that you ran into is that even though you brought all those servers together and you reduce the amount of hardware, what you didn't get is a lot of flexibility. Your VMs were essentially trapped in a certain server or on a certain rack. And so you got reduced hardware, but you didn't get a lot of flexibility out of it. And so what we're going to talk about as we talk about clouds and public and private and hybrid clouds is how to bring maximum flexibility back into the data center. So allow you to move your workloads anywhere you want, anytime you want, in order to really deliver maximum efficiency. I'm going to put up a phrase, and I want you to remember this phrase because we're going to keep coming back to it. Any service on any server in any cloud. What we want to be able to do is take any workload that you've got in your data center, put it on any server in your data center, and in fact move it to any cloud that you want to put it onto. It doesn't matter whether it's an on-premise cloud or an off-premise cloud. We want that service to be able to run anywhere you want it to run. If you need to move that workload around because you need to scale it up or scale it down or consolidate workloads because you can shut down machines, we want you to be able to do that. If you want to cloud burst that workload into the cloud, we want you to be able to do that to get more capacity. So this is about getting any service on any server and on any cloud. We'll keep coming back to that theme because you'll see how Hyper-V network virtualization is really focused on making this flexibility happen. Now, I'm going to spend a little bit of time talking about data center consolidation, multi-tenancy, and fundamentally why this is so hard to achieve today. I do this because it's important for you to understand the inflexibility that exists in the data center, some basic concepts around data center consolidation and multi-tenancy. It'll help to better understand what we've done with network virtualization. So let's consider an enterprise today that might have 3 lines of business: HR, finance, R&D. And today, you might have separate data centers. You might even have separate racks within a shared data center for each of these work groups. Maybe you've just done some mergers and acquisitions and had to bring together infrastructure from multiple different companies. Well, what we want to be able to do is have you bring these things together into a shared data center, a multi-tenant data center, where each of these groups has its own identity. So they have still the R&D network and the engineering network and the finance and HR network, but again, on a shared infrastructure. Imagine the same thing as you move to the public cloud. So different companies have their own shared data centers. And they want to be able to take those data centers and extend them out into the public cloud. And in the public cloud, they want to be able to run additional workloads, maybe a cloud bursting. Maybe you've just decided to move some workloads to the public cloud and keep some local. You want these 2 clouds to come together and behave like a single hybrid cloud. But on the right-hand side here in the public cloud, you don't want your stuff competing or stomping on or being affected by other people's stuff. You want it to look to you like a private cloud, like it's your own dedicated cloud, even though it's shared. So multi-tenancy is important in both the private cloud and in the public and hybrid cloud. And in fact, that's the common theme here. How do you get to multi-tenancy in either cloud environment? And in all 3 in both environments, you actually end up with a common set of requirements. First of all, you need secure isolation. We've talked about how the different workloads need to be able to run in that shared environment and be isolated from each other. Okay? My stuff should not be affected by your stuff. I should be able to run in an isolated, or what I think of as an isolated environment. I should be able to, the hoster, the person operating that data center, should be able to place those services anywhere. So just because I've come in with my workload doesn't mean that I need to have my workload run on a single rack. I want my workload to be able to run, or anyone's workload to be able to run anywhere and be able to be dynamically placed. And of course, we want to do all of this while maintaining SLAs for each of the tenants who are coming into the data center. So provide the right service monitoring and quality of service so that even though I'm running in a shared multi-tenant environment, I still can track the level of service that I'm getting from my resources in that data center. So multi-tenancy is important in both private and public cloud environments and requires a common set of capabilities. So let's just talk about some of the challenges that this creates. And these are the challenges that Hyper-V network virtualization was designed to address. First of all, and we've talked about this already, this idea that it's very difficult to do workload mobility. And we'll see an example of this in just a moment. Fundamentally, today, your VMs are actually trapped in a single rack, often a single server, but often on a single rack or a single part of your data center. IP addresses are used to identify your VMs, and your IP address defines the topology of your data center. So you don't have the flexibility to move things around arbitrarily. Well, as a result of not being able to move things around arbitrarily, you can't get your maximum resource utilization. Suppose that you want to shut things down at night. You don't need a whole lot of load. You don't need a lot of resources. Wouldn't it be nice if I could take all of my VMs and run them on a single rack and shut down parts of my data center? Well, that's the ideal. But if all my VMs are actually trapped on a single rack, I can't do that. I'm still going to keep all of my data center alive, even though it's at a lower rate, because I can't flexibly move my resources around. Even if I could move things around, well, it's just hard. I'm going to have to contact the networking guy, the storage guy, to make changes to the network of a storage infrastructure in order to move things around. Now, networking people are really scary people to talk to. I'm a networking guy, and you know, I have a hard time talking to other networking people. We're scary people. You don't want to have to go talk to that networking person every time you want to make a change to your data center. It adds time. It adds complexity. It slows things down. It doesn't give you the agility that you want. And in fact, those changes that that networking person is going to have to make are error-prone. We've found that even in our own data centers that human error, somebody making a change and misconfiguring something, is the most common cause of outages. So changes are not only complex, they actually are error-prone. And they not only slow things down, but there's high risk that you might actually cause an outage. Finally, if you're a hoster or you run a private cloud data center, this lack of flexibility makes it very difficult for you to onboard new tenants or new customers. If I've got a set of VMs that are running in my data center and I want to move it to your data center, today you're going to give me a set of new IP addresses that I need to use on my private resources. So before I can move my stuff into your data center, I have to go in and renumber all of the IP addresses, or I have to reconfigure my VMs. Well, OK, I can do that. But it turns out that IP addresses are everywhere. That affects my security policies, my intrusion detection, my monitoring, my load balancing. Everything is affected by those kinds of simple changes. That slows down my onboarding process and makes it more difficult for me to take my existing stuff and move it to a new data center or to a new cloud environment. And as a hoster, it slows down the customer acquisition process. Wouldn't it be nice if you could simply go to a customer and say, I can take your stuff as it exists today, and I can simply pick it up and move it in my data center and have you up and running immediately. And you don't have to change anything. That's the goal. Any service on any server in any cloud. So let's just talk very quickly about server consolidation and why this is so flexibility and why this is so hard. Today, most of our customers are running racks of VMs, and they're running each tenant in a single rack. Now, what you'd like to be able to do is take a rack and have all your VMs be mixed and matched on that shared resource. In fact, what you'd like to be able to do is do that across all of your racks. So as you roll out, if you've got a new rack, you can mix and match different VMs onto that rack based on your capacity needs. So you're not bound. The VMs aren't stuck on a single rack, and each rack can be a flexible pool of resources on which you add, remove, and change the set of VMs that you need at any given time. Okay? That's our ideal. Today, the typical way of doing network isolation is to use VLANs. Okay? Many of you are probably using VLANs in your data center. And VLANs work great. They provide you the ability to create a subnet and, in fact, have it span across multiple switches across your data center. The problem with VLANs, there's a lot of problems with VLANs. But one of the most difficult problems that they introduce is that they're very difficult to be flexible. Let's take this example where I've got some red, some blue, and some green VMs running in my data center. And you'll notice that I've configured all my switches with knowledge about the VLANs associated with the VMs that are connected to that switch. Now, suppose I want to introduce a new red VM. Well, as a result of configuring that red VM, I need to make sure that all the switches on that path are now aware of the red VLAN. So I have to go in and touch multiple switches. Again, That involves involving the networking person. That takes time, adds delay, and they might make a mistake. Now, you can automate some of these things, but again, it takes time. It can cause mistakes. If I need to add a red VM on the far side of a data center, well, I have to now touch even more switches deeper into the network. So VLANs are great for solving a problem at a rack level, maybe in a cluster. But as you start looking at your entire data center, you simply can't use VLANs as a scalable solution. They require changes to production switches. As it turns out, but as you look at your entire data center, VLANs don't have the scalability. Many of our customers are running out of VLANs. They simply don't have the flexibility to add more and more tenants into their data center. So what you have today is a resource utilization problem. We simply can't get maximum use of our resources because we can't simply move our VMs anywhere we want to move them. Well, we've run into this problem before. We ran into this problem when we had hardware that wasn't being utilized because our workloads didn't need all the hardware. So we solved that problem by virtualizing the resources. So if our network is not being properly utilized, let's virtualize the network. So let's talk a little bit about what we mean by virtualizing the network. As I mentioned, today, we've virtualized VMs. We've taken the individual VM, we run it as a virtual machine, or existing workload, we run it as a virtual machine, and essentially what the hypervisor does is it gives the VM the illusion that it's running on a dedicated piece of hardware, even though it's running on shared hardware. So we virtualize the CPU, the memory, the processor, so that the VM doesn't know that it's running on a shared infrastructure. Well, what we're going to do with network virtualization is we're going to take the entire network, the IP addresses, the default subnets, the broadcasts, the routing, and we're going to virtualize it. So the VMs who are running in that network think that they're running on a dedicated physical network. But instead, they're actually running on a shared network. Okay? So my physical network down there is running my own IP address space, but each of my tenants are running a private network, or what they think of as a private network, even though it's running on a shared platform infrastructure. Now, the nice thing about network virtualization, as we'll see, is that these virtual networks, these customer networks, are actually independent of each other. So they can have the same IP addresses, they can have the same subnets, they can route as much as they want, and we can hide all of that, and they can, in fact, overlap with each other completely transparently, just like VMs could do the same thing. So why do you want to do all this? Well, we've talked about all the pain that inflexibility creates. What we're really doing with Hyper-V network virtualization is bringing that flexibility back to the data center. So for workload owners, you have the ability to simply take your workload and run it as is in the shared data center. If you're an enterprise, you can simply now consolidate all those different tenants and workloads in a shared data center environment very quickly and easily without having you also get tremendous amounts of flexibility and agility. For the hoster, you can offer a new service. You can onboard customers more quickly by simply bringing them in without making changes. We're going to protect their IP addresses, their topologies, their infrastructure, run it in your data center just like they already run it in theirs. And in general, what you're going to get is better resource utilization and agility, the ability to move things around wherever you want to move them at any time, anywhere, any cloud. So that's what we're talking about, and that, I've given you the insight into kind of what network virtualization kind of is. So let me spend some time now that we've kind of talked about the problem, we've talked about what network virtualization tries to do, and we've kind of talked a little bit about the benefits. What I want to do is talk about how it works. So what we've said is that network virtualization gives you the ability to take an entire customer network and give it the illusion that it's running in its own private network on a shared physical environment. So let's walk through, we're going to walk through some IP addresses, some packet flows, and kind of see how this all comes together. I'm going to start by introducing a few terms as we go along. we're going to talk about the red customer and the blue customer. You'll notice that our red customer and blue customer both have VMs that are in a share that have common IP addresses, 10.0.0.5 and 10.0.0.7. So we'll refer to these two sets of customers with their own VMs, each running in their address spaces. And what we're going to do is place these VMs in a shared data center. Okay? So we're going to place these VMs down here on two different hosts, host 1 and host 2. These addresses, 10.0.0.5 and 10.0.0.7, are what we call customer addresses, or CAs. Okay? So these are the addresses in the customer's address space. These are running on two physical hosts, host 1 and host 2, running in the 192.168 address space. That's the address space of my physical network. We're going to refer to those as provider addresses, or PAs. Okay? Now, in the network, in the management tool, you're going to have a policy table. This policy table will be automatically maintained as your VMs move around. And what the policy table simply does is for each tenant, it maintains a current mapping between the CA and the PA. So it says that blue VM 10.0.0.5 is currently running on host 1. And red VM 10.0.0.7 is currently running on host 2. So that's a policy database which is maintained centrally and is delivered in real time to the individual hosts. So each host will actually maintain, actually not the whole routing table here, but a portion of a routing table that's relevant to the VMs that are currently running on it. Okay? So each host will have a little piece of that table mapping customers or tenants, their customer addresses, and the physical addresses associated with them. Okay, so we've talked about CAs and PAs. We've talked about this mapping table. Let me just introduce a couple more concepts here. Each VM is part of a virtual subnet. Okay? So just like a physical subnet, we've talked about the fact that you've got physical subnets today, or VLANs. We're now moving those into a virtual subnet. Okay? A virtual subnet is a broadcast domain. So if a VM sends a broadcast, that broadcast will get delivered to the other VMs in that broadcast domain, in that virtual subnet. Each virtual subnet has a unique ID in your data center, a virtual subnet ID, or VSID. Okay? We've tried to keep the names fairly simple to match what they really are. So each subnet will have a VSID. Each tenant in your data center might have a customer network. Okay? And that customer network can consist of multiple virtual subnets. Okay, so in the blue case, we've got a network over there that has 3 virtual subnets arranged in a topology. And the red network has 2 virtual subnets here that are arranged in a simple topology. So each customer might have a network of multiple virtual subnets. And then, as it turns out, each tenant in your network might, in fact, have multiple customer networks. So we might have my R&D VMs, my R&D network, and my finance network. Okay, so think about your customer or your tenant, with each of them having multiple customer networks, each customer network having multiple virtual subnets, and each virtual subnet having a VSID. Okay? So in your data center, we're going to bring all of these things together, multiple customer networks with virtual subnets. So the way we manage network virtualization is we use a technique called encapsulation. We use a standards-based mechanism called GRE, which is Generic Router Encapsulation. It's been around for a long time. We've made a couple of small modifications to the standard GRE protocol and have published those out there as internet drafts. It's wire compatible with the existing GRE protocol. And we use that GRE tunneling to move traffic across the data center based on where it needs to go, not based on the physical network. Okay, let me give you an example of how this is going to work. I've got here my 2 networks, same hosts as we had before, 192.168. I've got my red VM and blue VM, my red VM and blue VM. You'll notice that they each have the same IP address, even though they're running on the same physical host. So 10.0.0.7 is actually running together on the same physical host. You'll notice that these physical hosts have PAs that are in different subnets, even though the CAs are actually in the same virtual subnet. So what we're going to do is send a packet from each of the VMs, from the blue VM and the red VM, to the corresponding blue VM or red VM in the other host. And essentially what we're going to do is we're going to encapsulate that packet to get it to the final destination. So we're going to take the packet from blue 10.0.0.5 to blue 10.0.0.7, and we're going to take the packet from red 10.0.0.5 to red 10.0.0.7, and we're going to encapsulate it in a GRE frame. Now, the GRE frame is really the source address and destination address of the GRE frame are actually your physical network addresses. So your packets that are going on over the network are actually using physical addresses for their source and destination. However, inside that packet is your actual red or blue packet that identifies the true source and destination VM. Well, this is great, but how do you tell the difference between a red packet and a blue packet? Well, what we do is we embed the virtual subnet ID, the VSID, in the packet itself. Okay? So inside the GRE packet, there's a particular field called the key field, and we basically put the VSID information into that field. So two packets that look like they're going from the same source to the same destination and the same source IP to the same destination IP are differentiated because they'll have different values, different VSIDs in the key field. Now, this actually has some interesting advantages. Your network equipment can actually see inside the packet, simply go to that key field and figure out which tenant is sending that traffic. So you can actually do things like count packets on a per tenant basis by using that VSID information as a delimiter. On the receiving end, we'll simply open up that packet and extract the original source and destination packets, and we'll use the VSID information to tell us which network or which VM that packet should be destined to. So this is how we distinguish the blue packet and the red packet. I'll walk through a more detailed packet flow in just a few moments. But let me just talk a little bit about the architecture of how this actually is implemented inside Hyper-V. So many of you are familiar with the traditional Hyper-V switch. In Windows Server 2012, we've introduced the Hyper-V extensible switch. The Hyper-V extensible switch allows us to not only do a lot of great functionality like security and quality of service, but it also provides an extension model for third parties to provide new capabilities inside that switch. Well, underneath that virtual switch, we've introduced the Hyper-V network virtualization layer. Essentially, what the Hyper-V network virtualization layer does is the encapsulation and decapsulation of traffic according to what I just described. Okay? So the network virtualization layer is doing the encapsulation and decapsulation, but virtual switch is operating on the traffic. So you'll notice that the Hyper-V switch actually is seeing the traffic with this CA space. So they're seeing the switch is seeing the packets that the VMs generate, and we simply do the encapsulation and decapsulation at the very end. That's important because what we're actually doing inside the switch is we've got the packet coming out of a VM, and we also carry the VSID information associated with that packet. So you've got the access to the switch is actually operating on packets from the VMs based on the VSID. Your management traffic is actually kept separate. So we don't virtualize your management traffic. Okay? We don't virtualize your live migration traffic, your storage traffic, any of the traffic that originates from something other than the VMs. So VMs send the traffic, they get virtualized. Your management traffic, you can either have it go through a separate NIC. Many of our customers deploy, many of you deploy with separate NICs for management versus data. Or you can actually send that traffic through the Hyper-V virtual switch. That's fine too. And we simply know that it's management traffic and don't do any network virtualization to it. You can also mix and match VMs on the same switch. You can have some VMs that are virtualized and some that are not. Moving to the right of this picture, we show System Center. As I mentioned earlier, System Center 2012 SP1 does support the management of those policy tables in a Hyper-V network virtualization environment. However, this is all managed through PowerShell, so you could actually build your own management console if you wanted to and do your own policy management. What System Center is simply doing is pushing slices of a policy table down to the client, down to the host as needed, and that policy is then applied into the virtual switch and into the network virtualization layer on the host. Okay? So as VMs move around, System Center is aware of those VMs moving around and is making sure those policies are kept fresh and up to date on every host. Okay. So let's watch a packet. Let's watch a connection getting established through all of this infrastructure. We've got our same hosts, our red VMs and our blue VMs, and we're going to send a packet from blue 1 to blue 2. So from 10.0.0.5 to 10.0.0.7. Now, the first thing that a VM does when it wants to send a packet is it tries to figure out where that other VM is. So in this world, it'll generate an ARP. An ARP is simply a packet that a host or a VM generates that says, hey, I know the IP address that I want to send a packet to, but I need to find out its MAC address. So it typically sends it out as a broadcast packet on the local subnet saying, hey, I'm looking for this other VM. Can you tell me your MAC address? Now remember, this is difficult in the data center because that VM may be located anywhere in your data center, right? We've taken that service and we put it on any server. So we want to make sure that that VM can actually find the other VM that it wants to talk to. Now, so what we do is we receive that ARP packet coming out of that VM, and we do two things. First, we send that ARP packet to other VMs on the blue subnet that happen to be running locally. So if there's another blue VM on the same VSID, on that 5001 VSID, we'll send the ARP packet to that VM. However, in addition to that, we'll then forward that ARP packet down through the network, down through the stack to the network virtualization layer. You'll notice that what we're actually doing is we're attaching to that ARP packet the VSID of a VM that it originated from. So we're saying, look, I've got an ARP packet coming from this IP address, 10.0.0.5, but it's got from VSID 5001. That goes down to the network virtualization layer, and the network virtualization layer looks at that packet and says, oh, OK, I see it's an ARP packet. I know the MAC address of the destination VM. Okay? And if it doesn't know the MAC address of a destination VM, it'll ask System Center to download a policy associated with that destination VM, so we can figure out what the MAC address actually is. So the important thing here is that the ARP packets are not broadcast on the network. We're not enabling random packets to get broadcast all over your data center. Instead, we intercept the ARP packet, we obtain the necessary information, and we deliver it back up to the destination host. So we generate the ARP response up the stack, associate it with a VSID, and deliver it to the VM. So the VM doesn't know that the ARP wasn't broadcast. We're simply intercepting that ARP packet and delivering the right information for the destination VM. OK. So I found the MAC address of my destination VM. Now I actually want to send a packet. Let's see what happens here. So I'm going to generate a packet just like I normally would. 10.0.0.5 going to 10.0.0.7 with the MAC address, my MAC address, and the MAC address that I just obtained from ARP. Great. Well, I'm going to send that down into the switch. And the first thing the switch is going to do is attach the VSID information to that packet. Remember, all the packets on the switch are operating in the CA address space, so we want to make sure that each of the VM packets is disambiguated. So we attach the VSID to that packet. Goes down to the network virtualization layer, which looks at that VSID and says, I know that this is now a virtual packet, and I have to encapsulate it. So I look at my policy table to figure out where the physical host is that this VM is running on. And I'm going to create my encapsulated, my NVGRE packet, my virtualized GRE packet, that includes the original blue packet with a source and destination MAC address, the VSID information that I've got, and my physical source and destination addresses. And I'm going to send that into the physical network. And that physical packet is going to get routed through your network the way it normally would and get popped out on the other side. The network virtualization layer opens up this GRE packet and says, encapsulated packet, crack it open, pulls out the VSID from the key field, pulls out the source and destination, pulls out the original blue packet, and pushes it up into the switch. Now your switch can manipulate that packet as needed. You run your switch extensions. Maybe you're running an extension from one of our partners who maybe it's an extension from 5.9 that does packet firewalling, or maybe it's a monitoring extension from Inmon that does packet monitoring and counting. You do all your packet processing in your switch, and then that final blue packet then gets delivered into the blue VM. You notice that what the blue VMs see is what they'd always see. They have no idea that this is all happening underneath them. Okay? They're just sending packets happily to other blue VMs. And what's happening is that network virtualization is taking care of finding the destination VM, moving the packet to that destination VM, and making sure it gets delivered. OK. So what we've seen is that Hyper-V network virtualization gives you the ability to have your individual VMs continue to operate with their own IP address space in their own virtual subnets and not be aware that they are physically running, possibly on different VLANs, in different parts, in different racks, in different clusters, anywhere you want to have them run. And network virtualization is taking care of hiding that information from the VMs and making sure that packets get routed anywhere they want to go. You'll notice that even those packets are actually on the same, in this example, the packets are actually on the same VSID. It actually doesn't matter which VSID they're on. If I've got two blue VSIDs, two blue virtual subnets, the first source VM can actually be sending a packet to a different virtual subnet, and the network virtualization layer will actually take care of routing it. It will actually look up that destination VSID and route the packet to the right destination VM, even though they're running on different subnets. Okay, so we're essentially flattening that topology and having each host be able to route the packets directly to where it needs to go. That's the simplest case. We do support the ability for you to actually replicate the topology. So if you actually want to have all your cross-subnet traffic go through a dedicated host or router or switch, we can do that too. But in the default case, we simply take the entire blue network and we reduce it down and hop to hop and direct route the traffic from one VM to the next based on its physical location. OK, so what we've seen is the ability to how this works. Let's show an example of how this actually is managed through System Center Virtual Machine Manager 2012 SP1. So what I'm going to show here is I've got a physical network here laid out in SP1. It's got two subnets, two physical subnets, 10.0.0.1 and 10.0.1.0 and 10.0.2.0, which are laid out inside my data center. And what we're going to do is look inside these two physical networks to understand the physical hosts and the ability to do cross-subnets live migration for VMs in the blue network. Okay, so what we've got here are two physical networks. We're going to go in, and we're going to look at our physical hosts. I've got two physical hosts on one network, one physical host on the other network. Let's now look at our customers. You'll see that our blue customer here and red customers each have VMs. And you'll notice that VMs actually have overlapping IP addresses. My blue, whoops. So we've got overlapping IP addresses. 5 VMs on my blue network, and 1 VM on my red network. These VMs actually are overlapping, and they're running on separate VSIDs, separate virtual subnets, but they're actually running even on the same host. We're going to look at these two particular VMs. You'll notice they're on two different virtual subnets owned by the same customer. And what we're going to do is initiate a ping between them. So we're going to initiate a ping from this source IP address to this destination IP address. You'll notice they're across two different virtual subnets, but they're owned by the same blue network. I want you to notice that the IP address for this VM actually came from DHCP. One of the new capabilities introduced by System Center 2012 SP1 is the ability for your customer VMs to actually obtain their customer IP addresses via DHCP. Okay, so you don't even have to statically provision IP addresses. We've kicked off our ping, and what we're now going to do is kick off a live migration. So we're going to bring this VM, we're going to drag it over to this other host. It's going to initiate our live migration, again, to a physical host on a different subnet. Okay, let's go back to our ping now. You'll see that our ping is continuing, and even during the brownout period, the ping is continuing uninterrupted, even though the VM is actually being copied from host to host across different subnet boundaries. You'll notice that we're pinging from our original source IP to our destination IP unchanged. The VM is completely unaware that anything is going on. As we approach the blackout period, we start seeing a couple of packet drops here. What's happening here is that the VM is actually being brought up on the new host, and the policy just got pushed down to notify the host about where the packet should now go. And you'll see the packets are now continuing to flow uninterrupted. Okay? So the VM, as you can see, has been evacuated from our original host and is now sitting in our destination host. So we've done a cross-subnet live migration. So just to summarize what we've done here, we had two customers. The two customers had virtual subnets that overlapped. We had VMs with overlapping IP addresses. Those VMs were actually on two different virtual subnets located on two hosts in two physical subnets. And then we physically live migrated a VM from one host to another across the subnet boundary and continued to maintain connectivity between those virtual subnets. Okay? We've done this without interrupting the traffic flow from the VMs, without the VMs having to be modified, and without the VMs being aware that any of this is going on under the covers. Okay? So very, very powerful. What you've just witnessed is the ability to now free your VMs from any host and move them anywhere that you want. This can all be managed using PowerShell, and what you've just seen is an example of the System Center 2012 SP1 preview that actually allows you to create these customer networks, these virtual subnets, and manage your VMs and the mappings to physical hosts. Okay, so what we've seen is what happens within your network virtualized environment. Let's switch over. Let's talk a little bit about how this integrates to the outside world. So I've got my subnets. And typically, the problem here is I've got all of my traffic that's being tunneled within my data center. But in order for that traffic to reach the outside world, it needs to be decapsulated at some point in order to reach the internet, or maybe I've got some physical resources that haven't been virtualized or don't run in my network virtualized environment. So here we need to have a Hyper-V network virtualization gateway. And the role of a gateway is simply to decapsulate traffic, to take my virtualized IP address space and make it into physical address space. Okay? We'll extend that. You can even run a site-to-site VPN on that network virtualization gateway if you want to actually extend your cloud to reach out to a remote cloud. So site-to-site VPN can actually provide you then the ability to create a hybrid cloud where your virtual subnet that's in your remote cloud is now running in that shared data center. We'll talk a little bit more about network virtualization gateways in just a few minutes. Windows Server 2012 does provide the ability to create and deploy a network virtualization gateway that includes a site-to-site VPN. We have a number of appliance partners that we're working with who are building network appliances that create a Hyper-V network virtualization gateway and site-to-site VPN. Packages and network appliance that you can just plug in and run. And a number of our partners are actually working on introducing network virtualization support into their switches. So you'll have a lot of different options for how to deploy network virtualization gateways. So start with Windows, or a network, or an appliance, or even a switch. Before walking through a set of deployment topologies, I want to just say a couple of words about security, because I'm often asked about how to think about security in a virtualized world. Well, Hyper-V network virtualization doesn't fundamentally change your security model, right? Think of this as really providing isolation among tenants, but it's not changing the fact that all your traffic is actually still going over a shared physical network. If you care about data security, you need to do data security in the hypervisor. You might use server and domain isolation or IPsec to protect all the traffic from VM to VM. Okay? In an environment that needs high data security, that's entirely appropriate. And you can simply run IPsec inside your VMs and it'll be completely compatible with network virtualization. In fact, in Windows Server 2012, we support hardware acceleration of IPsec traffic that originates from VMs. So you can actually move, if you're using IPsec today, you can actually virtualize and not sacrifice performance. Or you might do application level security using SSL. That's fine too. So Hyper-V network virtualization gives you isolation and multi-tenancy, but you can still do security, higher levels of security at the application or VM level inside this environment. Okay, so we've talked about how Hyper-V network virtualization works. We've talked about live migration. We've talked about security. Let's talk about a few deployment scenarios. Let's talk about how you can actually deploy this in your data center. So here's an example of a private cloud deployment. Okay? On the right, we've got my consolidated data center that's running Hyper-V network virtualization. I've got a set of subnets. I've got a Hyper-V network virtualization gateway. And on the left-hand side, I've got my physical existing corporate network. My clients, my existing servers, they're running on the left-hand side. And the network virtualization gateway is providing the decapsulation and encapsulation of traffic back and forth between the corporate network and the shared data center. In fact, there's a picture of a topology that we currently have deployed inside Microsoft as a private cloud. What you see is on the bottom is our private cloud running Hyper-V network virtualization. We have a set of common shared services that are provided to that private cloud, DHCP, and then a network virtualization gateway. On the top side is our existing physical network. Okay? What we've simply done is taken a set of subnets that we have running inside our private cloud. We advertise those subnets through our default router. So traffic from the CorpNet gets routed through a default router that pushes the data into our network virtualization gateway. So the CorpNet just simply sees these as a set of subnets that get routed to the left-hand side there. Through the network virtualization gateway, the traffic then gets encapsulated and delivered into our private cloud. And then within the private cloud, I've got the full flexibility to move those VMs anywhere in a multi-tenant way. So this is an example of taking any service that I want that's running on those subnets, moving it into the cloud, and then running it on any server that I want to run it on. So this is a simple private cloud deployment. Well, we've talked about that private. If I could simply extend that private cloud into the public cloud. So if I wanted to, for example, take some of those subnets and move them into the public cloud, all I have to do is add a site-to-site VPN to either side, or site-to-site VPN on both sides, and now I can take an entire subnet and move it into the public cloud. In fact, I might have a hybrid cloud where some of my VMs are virtualized, some of my subnets are virtualized locally, some of my subnets are virtualized remotely, and I just have to set a routing policy that knows which subnets are where. Okay? And then site-to-site VPN takes care of moving the traffic back and forth. Okay? So this is a hybrid cloud deployment. I'm going to show you an example of a hybrid cloud deployment that was pulled together by one of our partners, F5 Networks. And what you're going to see in this example is that we've got two networks, two customer networks, and what we're going to use is Hyper-V network virtualization to enable an easy and seamless migration of some of my resources from my local network into a consolidated data center. And then we're going to see how Hyper-V network virtualization enables me to move some of those resources from my consolidated data center out even to a hosted cloud and to Office 365. So with that, I'm going to show a video here. And if we could get the audio.
As cloud computing gains momentum, many organizations are choosing to dip their feet into the cloud, to gradually migrate services and resources off-premise. To effectively control their environment, cloud providers typically need to dictate IP addressing for their customers' cloud-based resources. Changing an organization's address structure, even partially, can be daunting. Fortunately, there is a solution. Windows 2012 Hyper-V Network Virtualization allows customers to maintain their current IP addressing while enabling cloud providers the flexibility to co-locate tenant virtual machines on the same physical network, even the same host, while maintaining tenant isolation. In this brief demonstration, we'll take a look at the Exchange environments for two mock organizations, F5 Demo and F5 Agility, and how they make use of Windows 2012 Hyper-V Network Virtualization, along with F5's Big IP and Access Policy Manager, to provide a highly available, secure, and flexible environment. Our first organization, F5 Agility, has recently started to migrate its user base from Exchange 2007 to their recently deployed Exchange 2010 environment. Additionally, they've made the decision to migrate their entire Exchange 2010 environment to the cloud. Most importantly, they want this process to be as seamless as possible to the end user. To aid in this process, the organization has already configured network virtualization between their corporate office and the cloud provider. In addition, a Big IP Virtual Edition with Access Policy Manager has been deployed at the provider and configured to manage traffic flow, as well as provide pre-authentication and single sign-on to the existing on-premise Exchange deployment, regardless of which version is being accessed. Migrating the Exchange environment is as simple as running a PowerShell script that modifies network virtualization configurations, monitors and manages Big IP pool members, and migrates virtual machines from the corporate office to the cloud provider. Since the client access servers are deployed behind and managed by the Big IP already, the migration can be completed with little to no end-user disruption. Now that the migration is completed, let's take a look at a typical Outlook web app sign-on experience for both an Exchange 2010 user as well as an Exchange 2007 user. As you can see, users are able to access their mailbox from a single URL regardless of which version of Exchange they are on or whether the server is on-premise or up in the cloud. Our second organization, F5 Demo, is currently using Exchange 2010. However, they are now starting to migrate their user base to Office 365 and want to provide single sign-on to both Exchange 2010 and Office 365 users. To further promote high availability, the organization has decided to migrate its ADFS farm up to the cloud. Like the previous deployment, a Big IP Virtual Edition with Access Policy Manager has been deployed at the provider and configured to manage traffic flow as well as provide pre-authentication and single sign-on. And like our previous organization, migration of the ADFS farm is done via PowerShell script. The Big IP with Access Policy Manager provides a single sign-on experience for all F5 demo users, whether their mailbox resides on-premise or is hosted online. By combining F5's Big IP and Windows 2012 Hyper-V network virtualization, organizations and providers have a scalable, highly available, and flexible environment in which to deploy their applications.
So as you can see, Hyper-V network virtualization provides a pretty powerful way to move any service, literally to any server or even to any cloud. We've been working with a number of partners across the industry to really bring network virtualization to life, whether it be partners who are building network appliances that I mentioned earlier that provide the Hyper-V network virtualization gateway. A number of our partners are actually building switch extensions that are going to be multi-tenant aware that allow you to manage traffic coming from multiple VMs, multiple tenants in a common virtual switch environment. We've got a number of our partners who are building silicon network cards that are going to be capable of optimizing GRE traffic flow and accelerating the delivery of GRE traffic. And a number of our partners who are working on switches that are going to become multi-tenant aware and provide network virtualization. So across the industry, network virtualization is becoming a very big deal and is getting broad-based support. And we very appreciate our strong partner ecosystem that's really going to help make network virtualization a reality. So I want to come back to the original problems that we talked about. First of all, the fact that we didn't have that one of the challenges in a multi-tenant data center was limited workload mobility. And what we've done with network virtualization is made it possible for you to move your VMs anywhere they want. The IP address associated with the VM is no longer constrained. The topology that the customer brings you is no longer a constraint. You can deliver that entire topology on any network anytime you want. You can now move your VMs anywhere, which means that you can actually do resource consolidation. You can bring up a new VM, a new rack, bring things together, and shut down racks you don't need. So you can get more efficient resource utilization. You don't have to modify the network in order to make this all happen. Network virtualization works on top of any network topology that provides the ability to move packets. It doesn't matter whether you've got VLANs. It doesn't matter whether you've got subnets. As long as you've got a well-connected network, we can run network virtualization on top. Okay? The whole idea of network virtualization is to run any subnet on top of that physical network environment. Because you don't have to modify the network, you're getting the operational efficiency. You don't have errors. You simply make a decision about which VM you want to run where, and the policy gets automatically updated. We saw an example of that, how we simply drag and dropped a VM, and the policy automatically got delivered and updated for you, so there was no room for error. And finally, it's very easy now for you as a hoster or a cloud operator to simply go to a customer and say, look, I can take your VMs, I can pick them up, take your subnets, and run them tomorrow. I don't need you to make changes. I don't need you to do a lot of planning. I've got the capability now to run your existing resources in my network, whether it be for cloud bursting or operational efficiency or disaster recovery. I can run your network, run your resources anywhere. I want to close with a few words about software-defined networking. It's a term that you're going to see a lot, hear a lot about. Software-defined networking fundamentally is the ability to use software to define what a network looks like, to configure, operate, and manage your network, and make your network do what you really wanted it to do all along. Software-defined networking really delivers a lot of the core premises of what we've been talking about today. The ability to get agility, to simplify your operations, and to get greater scalability, to run your network, to run very large networks across your data center. Windows Server 2012 and System Center 2012 SP1 together bring you key elements of software-defined networking. In particular, they give you the ability to create virtual networks, deploy those virtual networks across your data center, and manage those virtual networks. Our partners have been extending that support through gateways, network cards, policy management, load balancers, and other equipment which is capable of operating in a world that's being configured and managed through software. So Hyper-V network virtualization is all about any service on any server on any cloud. We've seen the ability to deliver any service we want, move it anywhere we want to move it, manage your VMs centrally, and move it across the cloud through cross-premise connectivity. All of the components you need are built into Windows Server 2012. You can manage it using PowerShell, using your existing management tools, or you can use System Center 2012 SP1 to manage Hyper-V network virtualization. We've got built in the ability to do site-to-site VPN connectivity for your hybrid cloud. Our hybrid cloud solution actually interoperates with third-party site-to-site VPNs, or you can simply use a third-party site-to-site VPN solution in conjunction with network virtualization. So it's an open platform, open solution that really allows you to get maximum flexibility in a multi-tenant environment. We're very excited by Hyper-V network virtualization. We think it's going to really fundamentally change the way data centers are deployed and managed going forward. If you want to learn more about network virtualization, there's a number of related talks here at the show this week. Bob Combs gave a great talk yesterday about the extensible virtual switch. You can watch that on video. It talks a lot more about the details of how network virtualization works and what capabilities the virtual switch can provide. There's also some great talks by the System Center team that talk in more detail about management of network virtualization. I'm going to be at the booth in the TLC, actually right after this presentation, and then again tomorrow. So if you want to stop by and have additional questions, I'll also be here after the talk. There's a lot of resources on the web. We've got a white paper, getting started guide, a survival guide, and some information and some step-by-step guides for how you can take a set of servers and get a network virtualization environment up and running in just a few simple steps using PowerShell. And finally, I encourage you to please fill out your evaluations. They're very important to us. We read them very carefully. I hope you enjoy the rest of the show. Thank you for coming, and look forward to hearing about your network virtualization environments. Thank you.